Okay, now we are able to, now I want you to see how useful the unit circle is. So I'm going to use the unit circle to fill in these values. Now, I'm going to do this because I'm used to the unit circle. You're going to watch me reason. I'll draw a little picture and sort of figure it out. But you, for now, you are learning this for the first time. And so we just finished filling out the unit circle. You can look at the picture that we just filled out on your worksheet to come up with your answers. But watch how I'm doing this. This is how fluidly you should eventually be able to do this, okay? Some people in my calculus class were wanting a review. This is how fluidly you should be able to do this. So, right here, the sine of negative 120 degrees. What I'm going to do is draw myself a picture to figure out where this is on the unit circle. So, I draw myself a little unit circle, and I'm like, where is negative 120 degrees? Well, this is negative 90, and so another negative 120 degrees would be right here. Okay, well, what is this angle? This is really 240 degrees. This is really 240 degrees. And I'm used to this on the unit circle. I know that this one is 180, this is 210, this is 240. This one, the coordinates here are, this is going to be, the big one is square root of 3 over 2. The small one is 1/2. This is in quadrant 3. They're both negative. So what is the sine of 120, which is equivalent to 240? It's the y value. This is going to be negative square root of 3 over 2. How about cotangent of 3 pi over 4? Let me draw myself a circle. Where is 3 pi over 4? 3 pi over 4 is this middle one right there. The coordinates are always 1 over square root of 2, 1 over square root of 2. But x is negative, y is positive. Cotangent is going to be cosine divided by sine, or this value divided by this value, which is 1, but it's a negative and a positive, so this is going to be negative 1. It's negative 1 over the square root of 2 divided by 1 over the square root of 2, which is going to give me negative 1. Okay, the secant of negative pi over 6. I'm going to draw myself a little unit circle. Where is negative pi over 6? It is right here. This direction, pi over 6. What is my reference angle? Well, this is this is a 30. So that means these coordinates right here will be the big X, square root of 3 over 2, the small y, 1 over 2, and this is in quadrant 4, so X is positive, y is negative. Okay, now, they want me to find the secant. How I do this is I look at the cosine. The cosine of negative pi over 6 would be square root of 3 over 2, because it's the X coordinate. So that means the secant is the reciprocal. So this is going to be 2 over the square root of 3. All right, number 4. Here's my circle. Where is 720? Well, this is 0. One cycle around is 360. Another cycle around is 720. So it's coterminal with 0 degrees. So it's right here. The coordinates for this point are 1, 0. Okay, they want to know the cosecant, which is 1 over the sine, right? 1 over the sine of 720 degrees. Well, that's equal to 1 over, oh, the sine is 0. This is undefined. That's what this one is. All right, the tangent of negative pi over 3. So, this is just me thinking right here. I'm going to erase my thinking, and I'm going to have more room to think for number 5 and the rest of them. So, for number 5, the tangent of negative pi over 3. Let's figure that one out. Negative pi over 3, where is that? Here's my circle. Negative pi over 3 is going to be, this is negative pi over 6, this is negative pi over 3. It's right here. All right, so this is one where the x is short and the y is long. But we're in quadrant 4, so x is positive, y is negative. And so that's what I'm looking at negative pi over 3. The tangent of this is sine. So this is going to be sine negative square root of 3 over 2 divided by cosine 1 over 2. You can multiply the numerator and the denominator by the same thing, 1. Or, that might confuse some of you guys, you could also do a keep, change, flip. negative square root of 3 over 2 times 2 over 1. And these will cancel, and you'll find that the tangent is going to be negative square root of 3 over 1, or negative the square root of 3. All right, the sine of negative 3 pi. Where is negative 3 pi? Let's see. Negative 3 pi. Let's go here. Negative pi, negative 2 pi, negative 3 pi lands me here. It's coterminal with pi. The coordinates right here are negative 1, 0. The sine of this is the y value, so this is equal to 0. Okay, I'm going to double check my answers because it's a video and I don't want to have to go back and make a lot of emails saying why it's right or wrong. So I got happy with that one. I'm okay with that one. Number 3, 2 over square root of 3, okay. Undefined, okay. Negative square root of 3, 0. Okay, so far so good. Let's go ahead and tackle these. Ready? Let me think. Where am I on my unit circle for negative 120? So, here is a circle. Where is negative 120? This is negative 90, right? Negative 90. And so negative 120 would be another one here. Okay, this angle is a short x and a long y. A short x and a long y. But I'm in quadrant 3, so everybody's negative. So I'm doing number 7. So the cosine of this is negative 1/2. All right, 3 pi over 4. What does this one look like? Let me draw my circle here. 3 pi over 4 is there, okay? This is one of the pi over 4, so the values are the same. 1 over square root of 2, 1 over square root of 2. But it's in quadrant 2, so that means x is negative and y is positive. The tangent is going to be sine over cosine, or same thing divided by same thing, which gives you a 1. But it's a positive negative going on, so it's a positive and a negative being divided, so this is going to be a negative 1. The cosecant of negative pi over 6, right here. Negative pi over 6 means we're going clockwise. Negative pi over 6 is here. This is the same thing as a 30, right? So what are the coordinates here? This is going to be a big X, square root of 3 over 2, a small y, 1/2. We're in quadrant 4. That means x is positive, y is negative, right, like that. Okay, so cosecant is 1 over the sine. This is the sine, right? So the cosecant is going to be 1 over negative 1/2, or the reciprocal of negative 1/2. You can do a keep, change, flip, or you can just say the reciprocal of this, which is going to be negative 2 right there. All right, the cosecant of negative 180. Where is negative 180? Well, this is 0. If we go 180 this way, this is negative 180. What are the coordinates here? Negative 1, 0. Okay, the sine, this is 1 over the sine of negative 180, but the sine of negative 180 is 0. Oh, this is undefined. This is another undefined. Okay, how about the cotangent of negative pi over 3? I'm going to draw it over here. Negative pi over 6 is here. Negative pi over 3 is here. This is another of the 60s. So the coordinates for this are going to be short, small, and then big, square root of 3 over 2. Positive, negative. So these are the coordinates that we have for negative pi over 3. It's the same as positive 5 pi over 3. So the cotangent will be cosine 1/2 over sine negative square root of 3 over 2, or 1 over 2 times negative 2 over the square root of 3. These will cancel, and I get negative 1 over the square root of 3. Negative 1 over the square root of 3. Okay. Cosine of negative 3 pi, where is negative 3 pi? This, if I go here all the way around, I'm at negative 2 pi plus another negative pi lands me here. This is negative 3 pi. The coordinates here are negative 1, 0. The cosine is the x value here, which is just simply negative 1. Okay, that's how you can use the unit circle kind of quickly to find your values. If you don't have it in your head like me, but you can take a blank unit circle and fill it out real quick, and then you have it in front of you like you do right now. it works just the same. That's just fine. Just being able to come up with these values is helpful, and being able to fill out a blank unit circle is something I would recommend. So I've sent you a PDF of a blank unit circle that you can practice on. Just if you sit down a couple times a day and fill it out, or once a day for a few days, you will have it. You'll be able to be smooth with it and fill it in. There's a couple of things I need to mention. Quadrangles. Those are angles that hit on the x or the y axis. So if here's our unit circle, this angle right here, 0 degrees, 90 degrees, 180 degrees, and 270 degrees, or in radians, 0, pi over 2, pi, 3 pi over 2. Those angles have names called quadrangles. And these are the coordinates like 1, 0, 0, 1, negative 1, 0, 0, negative 1. That's a name I needed to tell you about. Then lastly, we're going to look at the fundamental identities. So let's just go over those real quick. These are things we have already been using, so you're used to these. But I just want to introduce them or talk about them officially. So they are listed on your little handout, so that's good. The first ones are ones we've been using a lot to find values, and it's the reciprocal one. So I'm just going to mention those. Let's see here. That cotangent is 1 over the tangent. That secant is 1 over cosine. That cosecant is 1 over sine. Also, this is not listed, but it's true. Tangent is 1 over cotangent. Cosine is 1 over secant. Sine is 1 over cosecant. That's also true. But this is when things are defined, okay? When we can only use these when the functions are defined. So for instance, if the cosine of theta is undefined, then you can't use this identity, okay? The quotient identities, that tangent is sine over cosine, that cotangent is cosine over sine. We've been using those to figure out our 6 trig values. So I think you've seen those. Let me talk about the Pythagorean identities. These are become important. So this is the Pythagorean identities. Oh, a marker that doesn't work. And they are good. I memorize one of these and I figure out the rest. So these are the Pythagorean identities. Pythagorean identities. This is the same Pythagoras who gave us the Pythagorean theorem, and you can see some similarities in this. It says that the sine squared of some angle plus the cosine squared of the same angle, sine squared of an angle plus cosine squared of the angle is equal to the number 1. This is the identity that I memorize. I commit this to memory. Also, watch this little algebra take place. This is the same thing as saying that the sine squared of theta is 1 minus the cosine squared of theta, or that the cosine squared of theta is 1 minus the sine squared of theta. Also, we use this, and then if you subtract one of these guys to the other side, these also become identities. Okay, but this is a Pythagorean identity. This is a big one, and I do memorize that one. It's not hard to memorize. Now, the next ones I haven't quite memorized, but that's okay. I can come up with them, and that's all that's really important. So, right here, if I can come up with the others, what I do is I take this one, and I divide both sides of this equation by sine squared of theta. So, if we do that, what we get here, sine squared over sine squared is a 1. Cosine over sine is cotangent, and so it's being squared. So this is equal to the cotangent squared of theta. And then 1 over sine is cosecant, but it's being squared. This is equal to the cosecant squared of theta. This is the second Pythagorean identity on your sheet right there. You can memorize this, or you can just do this and be able to do this, find these relationships. The third one on here, I don't quite have memorized, but I can come up with it and use it. I start with this one, which I did memorize. And then I go through and I divide both sides of this equation by the cosine squared of theta. And so then I have sine over cosine. I know that's the tangent of theta, and this is being squared, so we get the tangent squared of theta. Cosine over cosine is 1. 1 over cosine is secant, but it's being squared is equal to the secant squared of theta. And so this is the other Pythagorean identity. Likewise, you can adjust this. You can add or subtract things to the other side. Lots of times they'll talk about this particular one. They might say, okay, well, the cotangent squared of theta is equal to the cosecant squared of theta minus 1. Sometimes they count this as another identity. Or you might subtract the 1 and say, okay, tangent squared of theta is the secant squared of theta minus 1. These are also considered to be identities when you do this little bit of algebra right there. Lastly, they have the negative angle identities. Basically, this is saying, if you look at the sign of negative theta is negative sine theta, what they're saying is that the sine, the cosecant, the tangent, and the cotangent, these functions, these are odd functions. Which means that the sine of negative theta is equal to negative sine theta. So if you have had college algebra, and I think you all have, you learned about even and odd functions. And so if you take the negative of an x and it equals to be negative f of x, this is what an odd function is. That's what happens for all of these. Likewise, cosine of negative theta doesn't equal negative cosine theta, it equals to the cosine of theta. Well, that's saying, and the same thing for secant. So we find that cosine and the secant, these are even functions, which simply means that if you put the negative x in there, you get out the original function. That is what that's saying. So I just wanted to introduce those to you because you have a little bit of homework on that, but as we get into it, we'll see more and more about identity. So at least you've had a first look at that one.